This is an AQA GCSE chemistry question. It's from the Trilogy paper 2019. It's a higher question and we're looking at bonding, the periodic table, and it also includes a 6 marker. Have a go at pausing the video, try the question for yourself and then review later. So here's part A, part B, part C, and finally part D. In total, 14 marks available. So for part A, we have got sodium reacting with chlorine. What is the balanced equation for the reaction? Well, I'm going to go through and eliminate what we know to be wrong. So for example, we know that chlorine is a diatomic molecule, so we can get rid of the Cl and we can get rid of the Cl down here as well. We have also then got the fact that sodium chloride is NaCl, so we can get rid of those as well. Now that leaves us with our only option. Na and Cl2 react to make NaCl, with the balancing to get the 2 Nas and the 2 Cls there. So the correct answer is the third one down. On to part B, hot sodium is put in a gas jar of chlorine. Describe the observations made before, during and after the reaction. So in the first instance, you could describe either the sodium or the chlorine. So the sodium is a silver solid, the chlorine is a pale green gas. During the reaction, lots of options that you can give. There's a bright yellow flame, but you'll also get white smoke forming, and you will also see the green colour fade away as the chlorine reacts. After the reaction, there's a really important one to make here, a really important observation. We're making sodium chloride. Sodium chloride is common table salt, the salt that we eat in our food. We know that that's a white solid. That's what we're looking for here. On to part C, why is sodium less reactive than potassium? So we know that reactivity increases going down group 1, as it does for group 2. Sodium has fewer energy levels than potassium. You can start by describing the physical differences between them. That means the outer electron in sodium is closer to the nucleus. If it's closer to the nucleus, it's also got less electrons between the nucleus and it, so it is less shielded. Because of that, there's a greater attraction between the nucleus in sodium and the outer electron compared to potassium. And that means the electron is less easily lost, and so more energy needs to be put in. The converse of this is also true. You can talk about it in the context of potassium. Finally, for part D, chlorine reacts with sodium and with hydrogen. Compare the structure and bonding in sodium chloride and hydrogen chloride. So it's a 6 marker. We are bound by the leveled scoring. This time it's level 1 and level 2, and that means you're either getting 1 to 3 marks or 4 to 6. The key information, there's a lot here that we're looking for, but before I put them up, I'm going to recommend think about the bonding type and work from there. Sodium chloride is a metal and a non-metal, so it's ionic. Hydrogen chloride is hydrogen and chlorine. It's molecular or simple covalent. There's all of this information. I've already spoken about ionic and covalent, metal and non-metal, and 2 non-metals. We can go further. Ionic bonding, we transfer electrons. Covalent bonding, we share electrons. We have ions in sodium chloride. Hydrogen chloride is a molecule. Those ions are charged particles in sodium chloride. There are no charged particles in hydrogen chloride. And on it goes. Ionic compounds are giant lattices. Hydrogen chloride is molecularly covalent. We have the type of force that holds them together, electrostatic versus intermolecular. The fact that electrostatic is strong, intermolecular forces are weak. And on it goes. You can pause, take a look through all of them, but there's a huge amount of key information. My advice with bonding is focus on the key terminology for the right bonding type. And once you've learnt that, you'll be far more confident moving forward. And that takes us to the end of the question.